All right, so we are back. A couple of goals for today. One, we'll pick up where we left off last time. Recall that we were making this succession of server-related applications, super simple, but using Node.js, and then also most recently using express.js. And what was express.js the analog of in the PHP world? So Express is more close, Laravel itself. So Express is essentially the MVC framework that's pretty popular in the Node.js world. Bookshelf, which we'll see today via Tim, is an analog of Eloquent, which is an ORM, an object relation mapper that actually makes it easier to avoid writing low-level SQL code and actually express relations among various objects. So one of the coolest things, honestly, about Node.js is just how easily it lends itself to doing real-time applications. Things like chat servers or messaging servers, anything that you guys now use like Google Gchat or Google Hangouts or Facebook status updates or even Twitter if you're on their webpage. Everything is sort of real time or gives you the illusion of real time. And that's actually a pain in the neck to do with something like PHP and MySQL, right? What did we propose on Monday would be the means by which you could implement the illusion of real-time behavior with a chat server in PHP. What would you have to do? Alice sends a message, hits enter. Where does it go? Yeah. Into a database. And then what does Bob's browser have to do to actually see what Alice has said? Yeah.
Keep polling the database.
Keep polling the database, right? So an Ajax request has to fire every second, every few seconds, or we talked briefly but didn't look at an example of something called long polling. Anyone recall how that mechanism, just on a high level, works? Yeah.
It makes like one request, but it only gets a response when, like, it makes one request every like 30 seconds, but it gets a response when there is something new.
Exactly, yeah. So a browser still makes an Ajax request to a server, to foo.php, but foo.php just seems to hang. It essentially sits in a while loop for as many as 30 seconds typically, and only once the foo.php file realizes, ooh, there's a new row in the database, does it actually respond with an HTTP response. So you would think that this might otherwise hang the server, and it does to some extent, but it means there's a lot less overhead because you don't need a new TCP connection, a new HTTP connection to actually request data from the server. But Node.js comes with a very popular library called socket.io, which if you've never used is built on top of a technology called WebSockets, which is present in the most modern browsers. And what socket.io does is allow you to create essentially a persistent connection between browser and server that's very low overhead, so you don't necessarily have the same scaling issues that you might if you're constantly hitting the server in the world of PHP and MySQL and the like. And even for older browsers that don't support WebSockets, this library socket.io can fall back on Flash's implementation of sockets, and sockets is a networking thing from CS164, for instance, or it can even fall back on long polling itself. So they implement that same sort of workaround for actually maintaining the illusion of that connection. So socket.io is in the form of a JavaScript library. Essentially, if you use it in the form of a Node.js application, you not only install it as a package using something like npm, which we used on Monday, or you also include a script tag in your HTML file that says use the client-side library. So there's two halves to it. And what we've done here in the fourth iteration of Monday's sequence of examples is the following. So this file structure is reminiscent of a very common setup for Express.js. And thankfully, it's way simpler than Laravel was. Recall when you set up Laravel, you got a huge, nasty dump of a whole lot of files, vendor directories, lib, and it's very heavyweight compared to this. Now, in fairness, we've stripped away stuff that's pretty much a distraction, but all of the juicy stuff is really in Node modules. Just to give you a taste, if we look at Node modules, there's two modules or libraries that I've downloaded. This would be the equivalent of the vendor directory. One's called Express, which is like Laravel, but in Node, and socket.io, the one I just mentioned. So those exist so that we can do the following. If I open up, let's say, index.html, let's first look at the HTML. This is going to compose, this body, my super, super simple chat server. So there's apparently a UL with a unique ID of messages, and that's where one LI at a time, all of the instant messages are going to appear between Alice and Bob. And then there's a simple form with a text field and a submit button via which Alice or Bob can actually message each other. So the net effect, if I run this application by doing node space app.js, if I pull up a couple of browser windows, is that Alice might be on the right, Bob might be on the left, and just to be clear, there's no magic here. I've got one window in incognito, so there's no sharing of cookies or anything like this. These are two distinct users. I should be able to have Alice say, hello, Bob, click submit, And now you see on the left that Alice's message was sent, and nearly instantaneously on the right, no polling seemingly involved, Bob received the same message. And now if Bob says, say, hey, Alice, you see the opposite effect. So what's really going on? How much code do we need to write to implement this, a chat server, which you could now extrapolate mentally that everyone in this room, if this weren't on my appliance but we're on foo.com, we could all start chatting instantaneously with each other. So what's involved? And before I clear the screen, this is just socket.io being a little noisy. It's just printing out debugging information to the screen. There's really nothing else going on there. So let me open up app.js. So as before, we've got a few things at the top of the file. A bunch of requirements. So these are like libraries or sharp includes or require onces, whatever mental model you want to have. And just to recap, fs is used for what kind of functionality? So file system. So reading files potentially and stuff like that. And I use this in one place, as you'll see. Express, of course, is this framework we're using. And it's strictly not necessary. We could, like on Monday, totally create our own HTTP server from scratch by doing create server and all of that kind of code from before. But as we'll see, this makes things a little easier because all I have to do is on line 3 here, instantiate an Express object. I'll call it app, somewhat arbitrarily. I'll then tell the app to listen on arbitrarily port 1337, but that could be 80 by convention. And then lastly, I have a new line today, which is saying to require the socket.io library. And then by this chained approach with this dot operator, I'm just calling a method listen that's essentially telling the socket.io library to also listen to that same server for web socket connections. So now what? So what is this doing, these 4 lines of code here? It should look reminiscent of Laravel. What does this represent? This is a route. So it's just a route. So in app.js, aka server.js, depending on what people want to call it in their own applications, you have a convention of doing defining your routes. App.get means whenever you get a get request, go for literally / go ahead and call this anonymous function. And then the anonymous function in this case takes by requirement a request and a response, potentially some other things, but minimally these two. The request gives you access to things like HTTP parameters and headers and other juicy things. And then the response is the mechanism by which you can respond to the user. So this is super simple. Even though we didn't see quite the same code last time, I'm using the file system modules, create read stream method, which essentially does that, create a read stream, which means essentially start slurping up the bytes from index.html as efficiently as you can without necessarily waiting till you've read the entire file. And as you do that, pipe them, literally in the vertical bar sense, if you're comfortable with the Linux command line, pipe it to the response object. So there were 2 examples related to streams on Monday. We only looked at one, but you're welcome to look back at stream 0 and stream 1. Stream 0 did something similar to this. Stream 1 did something almost exactly like this. This is just a slick one-liner of saying sort of slurp something in over here and then start sending it here at the same time without doing a massive read and then a massive write. This approach is generally more efficient. So that's kind of old stuff, even if it was new on Monday. This is all it takes to implement a chat server with Node.js and more specifically socket.io. So how does this work? Let me move it up a bit. So IO is just the variable that refers to the module we required earlier. .sockets is just a property inside of it that gives me socket-related functionality. On is a common method that relates to what general notion? An event. So on, aka listen in some libraries, it just means on hearing this event, which is called connection. And I know this only from looking at the documentation. Whoever wrote the library defined an event called connection, which does what you would think when Alice or Bob connects. Go ahead and call this anonymous function, passing in one argument, the client, which is apparently some kind of object that represents Alice's connection or Bob's connection or Charlie or anyone else. And now we do the following. We tell the client, after he or she is connected, to listen specifically for a message that's completely arbitrarily called message:client. This is something that Tim and I came up with. It could be foo or bar. It's just some unique string that we needed to decide upon as the developers. Whenever Alice or Bob hears that event, this anonymous function should be called, and the data, the contents of Alice's or Bob's message should be passed into this event handler. And now what should the client do? Well, you can kind of read this fairly intuitively. The client should broadcast, otherwise known as emit, a message called message server, thereby signifying this message is coming from the server, not from the browser. And what should that message be? It's apparently the payload from whatever came from the client and we're just going to arbitrarily call it message. So a lot of this is arbitrary, sort of reasonable naming conventions Tim and I came up with, mostly Tim. And then we simply are creating, ultimately, a chat server that does what? When Alice sends a message and hits enter, what event apparently gets fired? Just to recap. Alice types a message, hits enter. Message client is fired. This code hears that. And now the server broadcasts what? What's the end result of this, really? Alice sends the message. Now the server rebroadcasts it effectively to everyone except for Alice. Why everyone except for Alice? If you just look at the documentation, client.broadcast.emit literally does that. Broadcast the message to everyone except the client who sent you that most recent message. So this is why you only see it once on each side. You don't see both Alice and Bob getting Alice's message. So that's it. This is a relaying agent, if you will, that's just taking in messages and rebroadcasting them out. And it's remarkably scalable. I mean, even with a super simple server and a few lines of code, you could certainly handle hundreds, if not thousands, of concurrent simple messages going back and forth like this. And just imagine the complexity now of doing this in PHP or Laravel or MySQL and how much code you would have to write in order to actually achieve that. Now, in fairness, this isn't persistent, right? If the server goes down, we lose the entire history, so it's not quite a perfect translation, but it's that straightforward. Let's look at the JavaScript code we skipped over earlier. This is Alice's and Bob's client, the web page they're using. Now let's look up here for a moment. There's a little more code, but it's pretty much just jQuery here. So notice that in the web page that I pulled up a moment ago, we include the jQuery library, the socket.io library. And as an aside, notice the difference here. / at the beginning of a path like this means what exactly? Where is jQuery.js? On what server? Yeah. It's on the internet. Yeah, literally the server called code.jquery.com. So why //? Why not just one slash? Where's the HTTP or the colon? What does this mean in general if you do / at the beginning of a URL? It's actually useful. OK, so what's obviously missing? HTTP. Now, if we reason through this logically, typically, you don't need to mention a server's name, right? Like if you just do /jquery.js, what is assumed by the browser? That the file's on the same server. So continue that sort of logic. If you don't tell it what protocol, what does the browser assume? Same protocol. So if you've ever visited websites that give you an error along the lines of insecure content on this page, it's because someone has hard-coded an HTTP ://URL for an image or a JavaScript file or CSS file, something like that in the source code of the page. But the page itself in the browser's URL is HTTPS. So this is just a fancy little way of saying, I don't know what the protocol is that this end user is going to use, but just make sure it matches so that Chrome and other browsers don't yell at the user. The only catch being the jQuery people have better set up HTTPS on their server, so they're actually listening on port 443. All right, meanwhile, this one here, this is kind of misleading. /socket.io suggests that there's a directory called socket.io on my server, but there's not. If we poke around, there's the node modules directory, but there's nothing public about this. When we configured socket.io to listen on the same port, 1337, essentially that library that someone else wrote is going to sort of insert some code into Node.js's environment and just listen for this path. That library has just configured a route for this. It's not a real directory. That would be in a standard location. OK, so now the interesting part. So when the document is ready, as indicated by this jQuery construct, first I'm going to go ahead and connect to a socket. What socket? Just to keep it simple, I'm going to connect to /. That's where the user is. I've kept the example simple. We're just going to connect to the exact same URL that the user has visited. Then I'm going to do the following. I'm going to tell Alice's or Bob's browser to listen for the message from the server. Again, this could have been foo or bar. Anytime you hear a message from the server, call it data, and then do this jQuery code, which I'm guessing most, if not everyone, is familiar with these days. But essentially append a list item to the existing UL, which was called messages, that literally says whatever the payload is of the chat message, followed by a hyphen, followed by received, followed by a space, and then a date time. And that's why, to be clear, if we go back to this, you get these additional bullets again and again and again with date times. Meanwhile, if we look down here, we just have to handle the form submission. So that was the receiving of an instant message. Here's the sending. And this is sort of unrelated to Node.js. listen to the form's submit event. When it happens, prevent default. This just means don't submit it to the server in the usual way, reload the whole page. We want to do this all via Ajax. Here's just some jQuery code to actually get the input whose type is message, whose name is message. Go ahead and get its value. Then go ahead and if you actually have a message, if Alice and Bob or Bob actually typed some non-zero number of keystrokes, emit on the socket a message called message client with that payload. And then down here, this is what makes it green as opposed to red. We simply output a client-side LI. So that's it. But all of this is just the setup. The real new stuff, I would argue, is just these 3 or 5 lines of code here. And that sort of hints at the power of Node.js, and with it, this particular library. So let's take a quick look at express.js. So what I'm going to try to do in the remaining couple of minutes here is set up a few ideas, a few techniques that will then take a couple minutes break. Tim will set up, and then we'll dive in deeper to a more interesting Express application and also to Bookshelf, the library that Tim actually wrote for the open source community that gives us eloquent-like functionality with MySQL and transactions and other such features. And he'll also dive in a little deeper to the language, JavaScript itself, how its object or non-class model works, otherwise known as a prototype model. So more on that to come. So let's take a look at 2 last applications here, Server 5 and Server 6, which are all sort of similar in spirit. These are not chat servers, but they use Express. So let's take a look at what this actually does. I'm going to go ahead and open up, I'm going to run this app with Node app.js. I'm going to go back to my browser and reload. And this is apparently all this server is doing. It's a super simple server that's apparently a search engine. So if I type in foo and submit, no search results for foo. I didn't get around to implementing the sophisticated backend. All it's going to do is echo no matter what you type, no results for foo, no results for bar. So how do we do this? Because there's a couple of pieces. One, there's clearly some inputs being provided to the server. Not Laravel, of course, but Node.js now. So we need to somehow get at that parameter queue. We're clearly doing some kind of view here. We're rendering a view. So maybe there's an opportunity for templates or variable interpolation. So let's take a look at the following. In app.js, for this particular server, this is all we have. 1, we require Express itself. 2, the path module, which just does some useful stuff like joining strings together and so forth for me. I listen on port 133.7. And now this is new. So it turns out that Express, like Laravel, supports different plugins and technologies and other things. And one of the technologies you can plug in is a view engine, which just means what templating engine do you want to use. Laravel had its own thing, but you can plug in different things. Different PHP frameworks have different ways of templating. EJS is just a common and a pretty simple engine that just lets you do things like the curly braces that you had in Laravel's syntax for substituting variables. It's a little different syntactically as all. So now there's this thing called middleware. So as you'll see in your own team's Node project, middleware is just kind of code that or libraries that you inject into the request response lifecycle of an application. In other words, these 2 lines are telling Express to do some extra work between the time it gets a request and between the time it sends that request to your own route, your code that you've written. So in particular, this one line here, use express.static and all of this complexity, this just means if you see a request that comes in for a static file, like foo.gif or foo.css or foo.js, so not a dynamically generated route, go ahead and assume it lives in the public subdirectory. That's all that's doing. It's sort of like mapping in Laravel everything to your web or your app directory, or your public directory, rather, in Laravel. This next line is just saying I want to use routes. I want to use things like app.get, which we saw a moment ago, and we'll see in just a second now. So app.get means listen for this route, / when you get it, call this anonymous function that takes in a request and a response. And now, just like Laravel, you have a way of rendering a template. Response.render, quote unquote, index renders a template called index. That's it. So let's suspend that thread for just a moment. Look at the contents of the views directory. And notice this too is super simple for now. There's index.ejs and search.ejs. I obviously want the first because that's the one I just tried to render. And we'll see in views index.ejs, actually entirely HTML at the moment. There's actually no templating going on. So I technically didn't even need to call it EJS. I don't need that functionality, but I kept it uniform. So that's it. This is what gives me that super simple form. So there's only one other route. If we look down here, I've said that this is what handles get/search. So the actual sort of Google-like handler for the form submission. When you get that path, call this anonymous function and render the template called search. And what does the second argument presumably mean? That looks like a JSON object of sorts, or JavaScript object. What's the role of that second argument, presumably? The actual query that the user typed in apparently lives in request.query, query referring to everything after the question mark, .q, which is the arbitrary name that I gave it, just like Google. And meanwhile, q : is just saying pass into the template search.ejs a key of q and a value of whatever q's actual value was. So that leaves just one file of interest to views, search.ejs. I kept this super simple too. It's mostly just HTML, except for one somewhat remarkable line, which is this syntax here, which looks like a bunch of different templating engines. This just means plug in the value of q and make it bold. So there's no actual search functionality. But it does kind of suggest how you would structure a skeleton of an application like that. Meanwhile, actually, let me show one other thing. Notice that I do have some HTML up here for CSS files and JavaScript files. There's nothing in those files at the moment, but notice there's a public directory, as I said earlier, for static files. So if I go in there, there's my CSS directory. If I go in there, there's styles.css. And there's no contents there, but that's how you would have publicly accessible files. All right, let's take a look at one other variant here. And then we'll introduce one idea and break. So this is server 6, the last. So this is almost identical, except for the bottom two lines, which look like this. So actually, there's a third line that's different that I've hidden. So let me back up slightly. So does someone want to propose what's going on here is, in layman's terms or technical terms? What's different about this version with respect to those lines and the topmost? What have I presumably done here, and why? Yeah, sure. Yeah, it looks like I've moved index and search to separate direct or something. I've factored them out. And that's so that, much like in Laravel, you could put all of your controller logic inside of routes.php with anonymous functions again and again and again. But that file, of course, would get pretty massive. So in routes.php, what most of you guys have been doing is you've specified the name of a controller class or even the name of a method that should get called. So the same idea here, even though the syntax is a little different. So up here, notice that I have apparently implemented my own Node.js module. And a module is just a JavaScript file that adheres to essentially one convention that we'll see in just a moment. So assume that all of my functionality for index and for search have apparently been put in this directory. And now I'm calling that whole module or package or library, whatever you want to think of it as routes, a variable called routes. So apparently in there, routes.index is a method called index. And apparently there's another method called search in this routes module or library. And I'm just routing it just so that I don't put all of my anonymous code inside of my app file. So let's go into routes. Notice there's just index.js. And if I look in here, this is the convention I meant earlier. So this is pretty arbitrary, but it's the Node convention. Anytime you implement your own Node.js library, aka module, you essentially can write any JavaScript code you want in this file. It will be very cleanly sandboxed so that any variables you choose will not collide with anyone else's library variables or methods or anything like that. But anything you want to expose to the outside world, a la a public method in Java or PHP or other languages, you have to plop inside of a global object that the author of Node called exports. So by doing exports.index, I am exposing to users of this module a method called index that maps to this function. So it's anonymous on the right-hand side, but I'm effectively giving it a name on the left-hand side and exporting it to the world so that you can call .index or .search. So to be clear, if I also had something like function foo in here that did something, that function would absolutely be operational. It could be called in this file, but no one in the outside world could ever call foo because it's not been exported by way of this dot notation. So that's all that's going on. Everything is nicely namespaced for you. So the end result, if I do node of app and reload the page, is that if I now search for bar, functionally, these apps are the same, but it's just sort of a step toward a cleaner implementation, certainly when you start writing more and more code. And that's all these are. Obviously not particularly sophisticated or complex, but essentially a starting point for what will be your first Node.js app. And what we'll do likely later this week or this weekend as you are finishing up on the PHP applications, we'll follow up with a pretty simple application for the team to dive into, similar in spirit to the warm-up exercise for PHP, which based on the mid-semester surveys, folks did find helpful going through the exercise of doing something fairly simple but fairly guided before you actually tackle something more on your own. So we'll follow up with that and essentially be due a week and a half from now, overlapping slightly with PHP deliberately. All right, any questions then on Express, on Socket.io, or confusion remaining from Monday, perhaps? No? All right, so hopefully one of the takeaways thus far is that there's, for some of these things, certainly a lot less overhead than you might have been used to. So let me introduce one last idea. So a very common programming paradigm in JavaScript that's actually present in jQuery in recent versions. So you might have actually seen this technique before, but it's also quite common in the Node.js world. It's common in Tim's own bookshelf library. So we'll revisit this in a more concrete example in a moment, is a solution to code like this. This is representative of code we saw on Monday. So read file in this context is not a real method. It's similar in spirit to fs.readFile, but assume that this is just some made-up method that does something very similar. So we ran into a few issues on Monday in general. So why is this a slippery slope, this callback paradigm of programming JavaScript? And by callback paradigm, I just mean this technique where you don't return values immediately, because that might block the server from doing something else that's useful. You instead call back, like the buzzers at Shake Shack, when you're ready to pass back a response as an argument. This is a slippery slope, or very quickly becomes annoying. Why? Yeah.
The code can become pretty unreadable.
Yeah. Minimally, it becomes kind of unreadable, right? If you have all of these callbacks, and if you're adhering to good style, it's getting pretty massively indented over time. And case in point, this example, if you sort of skim through it, is simply meant to open a JSON file and print it. Like, that's it. And yet we have some 8 or 10 lines here, which are already sort of nastily indented. We've got try catch, which, if unfamiliar, is an error handling technique that allows you to try something, and if it fails, you catch it, hopefully, without the whole program terminating. But there's just so much complexity. Like, you kind of have to think this through. And God forbid we do a couple of other asynchronous method calls, the thing is already going to be over here. You might think this is kind of a silly aesthetic, but this, because the callback paradigm is so common, at least in native Node code, this very quickly becomes tedious, hard to debug, the indentation starts to matter, so you can sort of chase things down. It's just not a very happy way of programming. So what folks have done in various contexts, Node among them, is try to simplify this. So for instance, promises is another way of thinking about writing asynchronous code that visually turns something like version 1 into this version 2. I claim, and this is, again, just sort of a mix between actual code and pseudocode. This is representative of how you would re-implement that exact same thing. Open a JSON file, parse it, and print it out using something called promises. And the key syntactic detail is that there's a chaining going on here. Notice that the only semicolon in the whole, actually, well, I don't want to mislead. This is not strictly necessary, but let's be consistent. Notice that the semicolon that refers to the opening of this whole statement is all the way down here. So while I've formatted this to kind of look like three statements that you might see in Java or other languages that have try and catch and exception handling more generally, notice that I've just chained the return value of each of these methods together. So what's going on? Read file, if this is a method that exists, apparently tries to read this file, .then. So then is a very common name given in the world of promises for the method that should execute if the previous thing succeeded. So it's kind of like a success handler. So then JSON.parse. Well, JSON.parse is just a method in the global JSON library, and it apparently adheres to, in this case, the promise model. So we can just assume that call this guy. And if he succeeds, then call this guy. And if that actually executes, simply console log the data in question. So where is the error handling? Notice I've sort of very blindly stepped off this ledge and just called this method and then this method without ever checking for problems. Well, where are those problems presumably handled? In these catch statements. So different libraries use different conventions, but in this case, then is sort of the success handler. Catch is sort of the error handler. And because we've not broken this chain, we just keep using dot notation to link together the original method invocation of read file, or the function invocation, any errors sort of bubble their way through the chain until they're actually handled, which is way cleaner than trying to deal with it every damn step of the way so that your code very quickly becomes unwieldy. And in this case, we're claiming that we're trying to catch what's called a syntax error. It's essentially a subclass of a more generic error. And if that happens, claim that it's invalid JSON. Otherwise, if it's a more generic error that we weren't expecting, just more generally say cannot read file. And now this is just meant to be representative code. But if you've programmed in raw JavaScript or in Java or other languages, this is procedural code, essentially. This is a more traditional try-catch statement. And that's the aesthetic and the functionality that promises are trying to give you, whereby you can think of it as just writing try and then catch, not having to worry at every single possible point where an error might happen. You can handle it all at the end as needed of a small block of code, and you can even distinguish among errors as you can in this case here. So the nomenclature that you'll see in the literature, maybe as Tim presents some of this stuff too, is that ideally you want promises to resolve. And resolving a promise means it finally returns, so to speak, but not in a traditional way, a value. So it either succeeds or fails, essentially. All right. Any questions then? That's not meant to be sufficient sort of exposure to promises, but just a mental model for what the code you'll just start to see.